called LabDM, which is specified in 0406. LabDM is, if anyone has worked with ISDN, there's also a LabD protocol, and it's a mobile version of that protocol, which again is based on HDLC, which again is based on IBM's SNA networks in the 70s. So it's not something that is completely new. It has a lot of history, just not inside no relation to the internet world. And then there's the layer 3. Layer 3 is really where a lot of attention I believe in protocol level security should focus. Layer 3 includes things like radio resource control, establishing and tearing down communication channels. This is where, if you have listened to Dieter Spahr's talk just before this talk in a different room, this is where his attack is based on. It is exploiting the way how radio channels are established in the radio resource layer of the layer 3 protocol. There's mobility management, which keeps track which phone is where, in which cell. And then you have things like call control for establishing voice and circuit switch data calls. And then you have things like SMS, location services, USSD. I don't even remember what the acronym means. Something like unstructured, whatever, data. So you have other protocols on top of that. And those are the protocols where I think the security relevant things to be found. In the layer 1, well, this is the RF layer, so well, yes, you can jam the radio, but that, it's not very exciting, I think. I mean, it's so easy, so why would you think a lot about it? The layer 2 is mostly about acknowledging and retransmitting packets, also not horribly exciting. So layer 3 is really where the attention should be. Now, on the ABIS interface, things are slightly different. What we have here is, as I said, the BTS is a transceiver. So it transceives between the ABIS wired interface and the UM interface, which is a radio-based interface. And the layer 1 and layer 2 of the UM interface, whatever your mobile phone talks to the network, is terminated at the BTS. The layer 3 is passed through into the core network. So you can look at the BTS as a vehicle to relay layer 3 data fragments or data segments between the phone and the core network. And the lower layers are terminated there. However, the ABIS protocol itself then has some lower layers that you need to implement or look at. This mostly, well, layer 1 is the E1 line normally, so regular ISDN E1 line. And in layer 2, you again have LabD, which is a regular ISDN layer 2 with some slight modifications. And then you get into organization maintenance layer, radio subsystem layer, or radio signaling link, RSL. And then in the higher layers on top of that, then you have the layer 3 messages from the phone, which are encapsulated into RSL packets at that interface. And now, this is, as I say, those protocols are the things where you can look at. Now, some of you might have been in a talk that I was giving last year, where I had just started playing with a BTS called a BS11, which is a big 48-kilogram Siemens monster, 200-watt power consumption, and so on. I bought that some time ago, and was playing with that. Now, it's a timeline. You can look that up on the slide. I will skip that too. In August 2009, which is sort of, well, as you can see, sort of 9 months after the project has started to implement this GSM network, OpenBSC, we had a field test at Hacking at Random 2009. Some of you might have been there, with 2 BTSs and 860 or more than 860 phones. That was the first sort of real-world exposure to OpenBSC as an open-source implementation of GSM protocols. And I think security research is closely related to open-source implementations. Because if you would use a closed-source GSM network in a box product, how would you be able to send frames that are not compliant with the spec, or to do anything that is not part of regular GSM network operation? So without an open source implementation of the protocols, I think security research is really, really hard and extremely limited on the protocol level. Okay, so OpenBSC is this GSM network in a box software. It implements the minimal subset of base station controller, mobile switching center, home location register, and SMS servicing center. It's free and open source software. Anyone can download it, anyone can play with it, and it supports 2 models of BTSs so far. That's because these are the only 2 that I have access to. If you buy some different model on eBay and you want to make it work, you will have to add the vendor-specific or device-specific parts yourself. It has classic 2G signaling, voice, and SMS support, and it implements the various protocols that I've been talking about, like the 0408 radio resource mobility management call control protocols and the lower layer protocols. Now, that is sort of, okay, now we have a network running, and we can register phones to our network. This is the fundamental tool we need to do security analysis on the protocol level. Next step, well, we can look at what kind of known problems are there in GSM networks. And if you do some research in that area, then you will very easily find things like no mutual authentication between the phone and network. So things like rogue network attacks are possible, man-in-the-middle attacks are possible, and this is what in the end enables the use of IMSI catchers for, well, law enforcement and more questionable purposes. Weak encryption algorithms are very well known. The fact that encryption is optional is also well known for people who have any interest in that subject. Well, there's the denial of service that Dieter has demonstrated earlier today. And we have also abominations like the radio resource location protocol, which very few people know about, which is, I think, has also been mentioned previously in other presentations at this event. But just to give you some background, it's a protocol how the network, and again remember, the network does not authenticate itself. Anyone can claim to be a network. It's a protocol where the network can obtain the GPS fix of a mobile phone, or even raw GPS data. It's not raw GSM data. Why would you obtain GPS data? So there's legislation in the United States that requires all phones sold after 2006 to have some extended 911 for emergency call protocol features, and the operators are required to be able to locate the phone very precisely. And in order to do so, 3 technical methods exist, and in the GSM networks that exist in the US, an FCC report indicates that all the GSM operators have voted to use or have decided to use the radio resource location protocol, which means the phones have a GPS receiver built in. The GPS receiver might be extremely bad. It might not even tell you that this phone has a GPS receiver. What they do is they tune the receiver to the GPS frequency, receive the raw GPS data, and then feed the GPS data into the network so the network can use all kinds of other information and the current ephemeris data and so on to calculate your position. And as I said, the network is not authenticated. So of course we can now send these packets and we can obtain positions, and it has been done at HAR. So if you have used your GSM phone in the test network, we had it hacking at random, and your phone supports that feature, then we have obtained your position at that event. Now, there are some other known security problems, and I think that's actually not one problem, but it is a whole class of problems or a dimension of problems. Is that, well, we have these proprietary GSM protocol stacks. There are only 4 of them, which is not a single point of failure, but, well, a quadruple point of failure. But not many implementations, and they have not received a lot of review because they've always been kept secret under very few eyes. And they run on a so-called baseband processor. Now, what is this? It's an ARM7 or ARM9 core. It runs some real-time operating system, often Nucleus, in some cases an L4 microkernel. There is no memory protection between tasks. Even on an ARM9, the MMU is not used. Then you have some kind of DSP in the model, depends on the vendor and so on. Now, the software stack on that baseband processor is, I have not seen any other way of implementing the stack. It is always written in C and assembly language, and it lacks modern security features. There's no stack protection, there are no non-executable pages. As I said, there's not even any memory protection between the tasks. There is no address space randomization. There is no virtual addresses in many cases at all. Well, and this is what 4 billion people carry around with them all the day, exposed to a network which does not have to authenticate itself. Right? Keep that in mind.